Hello people, in this lesson 2 of fundamental physics we are going to learn about physical quantity, base unit and derived units, and number 3, prefix of units. Now what is a physical quantity? A physical quantity should have two things. One is the value, number 2 is the unit. For example, my mass is like 90 kg, so 90 is the value and kg is the unit. My length is like 1.7 meter, so 1.7 is the value, meter is the unit. But not everything has a unit. For example, if you think about strain, which is the extension per unit length, so extension and length both have the unit meter, so they will cross out, and the strain doesn't have any unit. So we cannot call it physical quantity. So what about the base units? Let's go to them. Now if we look here, the base units are length, mass, time, temperature, electric current, amount, and luminous intensity. Now we all know the symbol for length. Length symbol is L and the unit is meter. Then for mass, the symbol is M and the unit is kg. For time, it happens, but sometimes we use T, sometimes we use a capital T. So let's use a small t here because we have temperature here too, and the unit is second. For temperature, the symbol is capital T and the unit is Kelvin. Now why not Celsius? Because Kelvin we don't have to use the minus, we can only use the positive values. And then electric current, we have the we call it I, the symbol, and the unit is ampere, A. Now for amount, it's the mole, and the symbol is N and the unit is mole. For luminous intensity, this is the one you're gonna need least. So we represent this by IV or I, and the unit is candela. We represent this by CD. Now these are the base units. That means any other quantity, it can be represented by the combination of this. But these quantities cannot be represented by the other quantities. Let me show you an example. For example, if you go for joule, 1 joule. Joule is the unit for work done. So work done, the basic form for work done is force into distance. So force unit is Newton and distance is meter. So we can write, and Newton is F equal to ma. So this is kg meter per second square into meter. So it can be represented by kg meter square second to the power minus 2. So these units, these are called the derived units. They will sometimes give you questions where you have to find the validity of the formula using the units. So if both sides have the same unit, then the formula is valid, and it mainly comes in the multiple choice. Now let's go to the prefix of the units. Now this is how people memorize it. We are not going to talk about the grammar here. Kelly hates drinking milk, drinks chocolate milk. This Kelly, this means kilo by K. Hates hecto, drinking deca, da, milk, meter, drinks decid, chocolate centi, millimeter, m. Now actually you don't need to memorize all of them. Let me just give you some of them. Okay. Now let's use the 1 meter. Okay. So you have 1 kilometer, that is 10 to the power 3 meter. Then 1 meter equal to 100 centimeter, and 1 centimeter, that is 10 millimeter. So these are the basic ones that you need. Sometimes you need the deci, and 10 centimeter is 1 deci, but this is not that this you don't need that much. Okay, so we'll just block it. Okay, but there are some other prefixes that you're going to need, especially when to define frequency or distance, which are bigger than kilo and lower than millimeter. But you can use something like a rhyme. Okay, you can use as rhyme as a minimum device, because we have mega, and then we have giga, and then we have tera. Now you can see all of them have their symbol are the capital letters. Okay, M, G, and T. So 1 mega is 10 to the power 6. This is 10 to the power 9. This is 10 to the power 12. Okay, so mega, giga, tera, 10 to the power 6, 9, 12. So say 1 megahertz is 10 to the power 6 hertz, 1 gigahertz is 10 to the power 9 hertz, terahertz is 10 to the power 12 hertz. And then we also have micro, nano, pico. So let's write micro, represented by mu. This is 10 to the power minus 6. Then we have nano, represented by n, that is 10 to the power minus 9. And then we have pico. Pico is represented by small p, and that is 10 to the power minus 12. So these are the main ones you have to remember: mega, giga, tera, micro, nano, pico. It sounds like a rhyme. All are 6, 9, 12, except these ones are lower than 0. These ones are greater than 1. Sorry, these ones are lower than 1. These ones are greater than 1. Now, so in a nutshell, we studied what a physical quantity is. It has a value and a unit. Then we studied what are the base units: length, mass, time, temperature, electric current, amount, luminous intensity. Now, especially give some importance to this electric current, because most of the time they'll ask you a question where you have to choose between charge and electric current, which is a base unit. So always choose the electric current. Then we studied the basic prefix. Mainly we need the kilometer, centimeter, millimeter relations, and then mega, giga, tera, and micro, nano, pico. So that's all for today. See you in the next